Okay, can you hear me? Can you hear me? Can you hear me? You can hear me, right? Shinan? Yes. Okay. Today, Dinet? Yes. Hmm, why it is repeat? Can you hear me? Okay. Give me a second. Okay, now okay. Yeah. Okay. Thank you for your wishes. Okay. Today our target is complete full electricity questions. Okay, electricity questions. This is now we have three tutorials, three papers. I think you all have papers. I have sent into the group. You can find in the group tutorial 1, it is very simple question. Tutorial 2, exam MCQ question. Tutorial 3, exam past paper essay questions. Past paper essay questions. Let's starting from are you complete tutorial 1? Okay, it is a very simple questions asking a perfect transformation, the perfect or that we call as ideal transformations, transformers, ideal transformers. Okay, what's the meaning of perfect scale? You know, if not ideal transformers, what's the meaning of this ideal transformers that we discussed in the lesson? What's the meaning? What's the meaning of ideal transformers or perfect transformers? What's the meaning? Yes, transformers that we already discussed about transformers. you can download this tube. All parts not you can find in the tube. It's a very bulk tube. It has how many pages? More than 30 pages, I think. Okay, this is the transformers. Transformers, there are mainly two main types transformers we discussed. What are the two main types transformers? Transformers types දෙක මොනවද? What are the two types? Now answers? Now we already discussed. Yeah, step up transformers and step down transformers. Step up transformers mean the voltage increasing. The more than primary coil, secondary coil has more turns. More turns. That means it is voltage increase. That's meaning of step up transformers. The step down transformers mean more than primary coil. So more than secondary coil, primary coil, more turns. More turns like this. More turns. That means the voltage is decreasing. Voltage decreasing. Voltage decreasing. Okay, different types that we discussed applications here. This is the ideal transformation. Ideal transformation. Ideal transformers. An ideal transformer is a theoretical transformer. It is not actual practical, not actual transformers. It is full theoretical transformer. Theoretical transformers that works without no any energy loss. That means when think this is the primary coil. This is a primary coil. And this is the thing, this is a primary coil, and this is a secondary coil. Primary and secondary coil. Primary coil and secondary coil, when energy transformation, there is no energy loss. There is no energy loss. Okay, that's the meaning of the transformers without any energy loss that we called as the ideal or perfect transformers. Perfect transformers. The same concept as a perfect transformers. Perfect transformers can the same concept. The same concept. The characteristic of ideal transformation, no energy loss. Everything we have discussed. You can go through this note again. The ideal or perfect transformers mean there is no any energy loss. That means efficiency 100%. That's why it is not practical transformers, but it is a theoretical. For our calculation, we consider as in physics, lot of this type assumptions in normally smooth surfaces, we consider there is no any friction. Okay, this type, that's also theoretical thing, not actual thing. Ideal or perfect transformers mean the transformers without any energy loss, 100% efficiency. Efficiency 100%. Efficiency 100%. Yes, efficiency 100%. And no resistance in the coil. No resistance in the coil. No leakage. No energy loss. Yeah, that discussed. Then the primary coil power perfectly equal to the secondary coil power. Primary coil power perfect equal to the secondary coil power. Secondary coil power. Then we can say the primary coil power we called as PV. PV primary. Sorry, VI. Sorry. P equal VI. VI, both primary coil. It is equal to the secondary coil power. Secondary coil power VSIS. Okay, using this concept, we can get relationship. Making up relationship. Now we have equation VP equal, sorry, VPIP equal VSIS. This is the basic concept of ideal transformation. Ideal transformer. There is no energy loss. Primary coil power perfectly equal to the secondary coil power. Primary coil power perfectly equal to the secondary coil power. That's mean now you can isolate this. If I got Vs and get Vp Is, sorry, now we can get relationship like this, Vp over Vs equal Is over Ip, like this. Okay, that's a relationship. That's a relationship. Using this ideal concept, we can get equation like this. I isolated Vp over Vs, Is over Ip. Okay, this is the basic relationship. Okay, in the previous part I told there is very simple equation like this. Very simple equation, Vs over Vp. That means the secondary coil voltage over primary coil voltage equal secondary coil number of turns divided by primary coil number of turns. Okay, then with this ideal concept we can get another full equation. What is a full equation? The Vp over Vs equal Np over Ns equal Is over Ip. Remember, this is the final equation about transformers. This is a final equation. How you can remember this? Voltage and number of turns, it is same. Pp. මේ දෙක මුඩ තියෙන. Pp, primary. But when it come to current, it is different, reciprocation. Is over Ip. Understood? Up to now, okay? That you already discussed. Make a මෙහෙමත් දෙන්න පුළුවන්. This one also correct. Now Vs over Vp equal Ns over Np equal Ip over Is. Current one is reciprocation. I got Isru? I terms only reciprocation. Anit පැත්තෙන්. Are you clear? Then I got the final equation about transformers. Both any equation you can use. Any equation you can use. Voltage and number of turns, it is same. SS, PP, SS, it is same. But current, it is reciprocation. Is it true? Clear? Okay, a perfect transformer connected to a 240 supply and have a current of 0.1 ampere flowing in its primary winding. Primary winding means primary coil. If the output voltage of the secondary winding are 12 volt, 12 volt. What is the current in the secondary winding? Okay, then it is asking Vp over Vs equal Is over Ip, opposite. Current enne හැම වෙලාවෙම always it is reciprocation. Current in other number of turns and voltage, it is same pattern. Always current reciprocation. Remember, current again reciprocation. Okay, then voltage, primary voltage 240. Secondary voltage 12. Primary current 0.1 ampere. Secondary primary current, secondary current is asking. Then primary current 0.1 ampere. 0.1 ampere. Is is asking. Secondary current is asking. Okay, now you can cross multiply it. It is 24 over 12. 2 ampere. Answer number 4. Are you correct? Amavi? Isru, are you there? Isru. No, Isru. Sandeep? Okay, very simple equation. Voltage and number of turns, it is same pattern. Voltage and number of turns, it is same pattern. Remember the equation. Again, no, don't keep anything to remember later. Complete everything within the class. What is the equation? What is the equation? What's the equation? Vp over Vs. Equal Np over Ns. That means number of turns. Okay, number of turns. Equal Is over Ip. Only current, it is reciprocation. They are same pattern. Finish. Are there any doubt? Any doubt about transformers? Shina? This calculation, this equation only correct for ideal transformers. Okay, it's only correct for ideal transformers because every practical transformer has an energy loss. Therefore, this equation not correct. But in our calculation, theoretical calculation, we can use the equation, no problem. Shina? Clear? Question number 2. A perfect transformer, same type. A perfect transformer have 10 turns in the primary and 200 turns in the secondary. Again, what's the equation? Vp over Vs. Not asking voltage. Then you have to get number of turns and equation between number of turns and voltage, right? Full equation now you need. Vp over Vs equal Np over Ns. Okay, using this equation, a perfect transformer have 100 turns in the primary and 200 turns in the secondary. 100 over 200. When the primary are connected to a 120 volt supply, 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 current 10 ampere. That means primary current is 10 ampere. What is the voltage and current of the secondary coil? Okay, first of all, I am going to get the voltage. Then 20 to 20 cancel. Then it is Vs equal. Vs means secondary voltage. Secondary voltage equal 2 into 120, 240. 240 voltage. Then this one wrong, this one wrong. You have three answers. Three answers. Now you have to get the it is 240 voltage. 240 voltage. 120 voltage and 240 voltage. 240 volt. Then now you have to get second equation again. Vp over Vs equal Is over Ip, reciprocation. Current at the reciprocation. Current reciprocation. Then Vp over Vs mean Vp 120, Vs 240 equal Is is asking, secondary current is asking. It is 10 ampere, it is given, primary given. Then 0 to 0 cancel. It is 2, it is 1. Now cross multiplication, 2Is equal 10. Then Is equal 5 ampere. Is equal 5 ampere. Is equal 5 ampere. Answer number 1. Answer number 1. Is equal 5 ampere. I got. Now any transform question you can do. If you got the equation pattern, very simple. Question number 3. Question number 3. What's the answer for question 3? I got the answer number 3. I got. Yeah. Very good. Very good. Yeah. It is 11. Okay, let's see. Okay. An electric unit cost 55. Unit cost 1 unit, 1 electric unit. 1 electric unit mean 1 kilowatt hour equal 55. It is given 55. A 2000 watt electric 2000 kettle electric watt takes 6 minutes to boil some water. What's the cost for boil this water? What is the cost for boil this water? Okay, then how we get the electric power? Remember, E equal always PT. Remember this equation very well. Remember this both equation very well. Remember this both equation very well. P equal VI. P equal VI. This is the power equation. And E, energy equal PT. Power multiplied with time. Then using this both equation, we can say again energy equal, instead of this P, we can substitute VI. Energy equal VIT. Okay, we have three main equations. They are the key points. Key points. Compulsory equation you have to remember. P equal VI. This is the power of any electric device. The E, energy amount, power multiplied with the time. Power multiplied with the time. The energy, instead of P, we can substitute VI, then VIT also a energy equation. Okay, using this equation, we can use this equation to find the number of units, number of energy units, number of electric units. Then it is P. The power 2000. The rule is you need to substitute in kilowatt. Kilowatt substitute කරන්න. Then 2000 watt mean 2 kilowatt. 2 kilowatt into time. Time 6 minutes. 6 minutes you can't use. You have to substitute in hours. Then 6 over 60. Understand? 6 over 60. Then it is hour. Then we can get how many kilowatt hours. It is cancelled. 30 is 5. 1 over 5. What's the meaning? What's 1 over 5? No need decimal value. 1 over 5. 1 over 5. 1 over 5 kilo hour is the kilo electric unit used for boil this amount of water. Boil this amount of water. Then the cost we can calculate. Cost we can calculate. 1 over 5 kilowatt multiply with 55. Multiply with 55. Multiply with 55. Then 5, 55, 11. 11 cent. I don't know what's the unit they given, but it is, it should be actually rupees. Okay, whatever. 11. Cent 6 over 60. 6 over 60, 1 over 10. Yes, Amavi. But again, 10 and 2 cancel. I capital method 5. Then 1 over 5. Okay. Question number 4. Question number 4. Two resistors are connected in parallel, 5 and 15. The power dissipated by the 5 ohms resistor is 40 watt. The 5 ohm one, it is 40 watt. 40 watt, it is given. 40 watt. What is the power dissipated by 15 resistor? 15 ohm resistor. 15 ohm resistor. Okay, how we can get this? How we can get this? How we can get this? Okay, what is the theory? What's the theory? Okay, what you got answer? Okay, they are compulsory question in the exam. If you go through our MCQ questions in 2024 question also, this is an exam question, and 2021 exam question also, this is the exam question. In 2017 also same, this is the question. Okay, the power dissipation is asking. Okay, the power P. What is the equation? P equal VI. 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 But using this equation, we cannot get this value. We cannot get this value. Therefore, we change equation in P equal V. Instead of I, I'm going to use V equal IR. According to V equal IR, instead of I, we can use V over R. V over R. V over R. Then the pressure equal, power equal V squared over R. V squared over R. V squared over R. V squared over R. Now, if you got this 5 ohm resistor, it is power 40. Power 40. Now, power 40. Now, V squared, no. R5. Then we can get the V squared value equal 200. V squared equal 200. It is voltage. V squared, but V equal 200 square root. Okay, that don't need. V squared equal 200, that you found. Okay, now I am going to substitute. Now it is a parallel system. The parallel two resistors. Then how about the voltage? The voltage is same or difference? The voltage of same or difference? The voltage same. In parallel resistor systems, I told the voltage is same. But the current is dividing. According to Kirchhoff's second law, first law, current dividing. But voltage same voltage. Then the P equal VI for this one. P equal VI. I'm going to use the same equation. P equal V squared over R. Same as this. Then V squared value 200 value. R15. Okay, what is this value? 200 over 15. This is the power. What's the value? 200 over 50. Amar, what's the value? 200 over 50. Yeah, 13.33. But it is easy. According to answers, I can 200 I can divide by 5. It is 14. 200 divide by 5. It is 40, right? 40. 15 divided by 5. It is 3. 40 over 3. Answer number 4. No, 13.3. 40 over 3, 13.3. 200 over 15, 13.3. But according to answers, you have to adapt. Are you clear? Amavi, I got the answer. Shehan, good, Shehan. Okay, this type very simple questions. Actually, this electricity lesson is not too hard. The problem is these electricity questions coming in the section of 20 MCQ 25 to MCQ 45 to 48 questions. Normally in exam paper 45 to 48 question little bit advanced. Not this lesson more advanced. Therefore, in electricity lesson, with advanced questions coming, advanced and time taken questions come. But don't afraid. Bayan එපා ඒ ලකුණත් ගන්න පුළුවන්. At least two questions coming. Two electricity. One question is simple and one advanced question come. ඒ advanced එකත් ගන්න පුළුවන්. Simple. But you have to practice. Without practice, you can't get this. If heating coil in a elastic iron is replaced with coil of same type but much more shorter length, which of following statement is true? Same type coil, oh, okay. Okay, what I told, a heating coil in an electric iron is replaced with coil of same type but much more shorter length shorter in length. Which of following statement is true? Think this is the original plate. This is a new plate. Same material. It is short. Iron become too hot. Is it correct? Iron become too hot. Too hot mean more than initial one, more than original one. Is it too hot or least hot? Heat එක අඩුයිද වැඩිද? What do you think? The new one is a short coil. Yeah, that we already know. There are three main factors. I told there are three main factors affect on the resistance of any conductor. What are the factors? The length of the conductor, the cross section area, and the material type. Now the material type is same type. Material type is same, but it is different length different. I told when increase the length, the resistance is increasing. But when decrease the length, the resistance is decreasing. Therefore, the too hot, it is wrong because the shorter one, the resistance low. That's why it's the heating ability low. The coil may be burned out. It is possible. Fuse is, yes, that means fuse එක off වෙන්න පුළුවන් due to burnout. They are the possible way. They are the possible way. A, B, and C. B and C. Answer number 4. Answer number 4. Okay, which units are equivalent to volt unit? Which units are equivalent to volt units? Okay, what's the answer? What's the answer? Which unit are equivalent to volt unit? Volt. What's the answer? Sorry. It is not volt. It's a mistake. That's a. It is what? Sorry. It is what? Which unit is equivalent to what unit? Now get the value. What? What unit? W. Okay, what is the value? What? P equal VI. P equal VI. P equal VI. Okay, what's the answer? What? This correct answer should be what mean joules per second? Yeah, it don't need it. Don't. Question is wrong. Okay, go to 7. Okay, instead of 1,000 bulb, 10 volt, say 10 watt saving bulb were used. If light is on for 4 hours every day, how much electric unit save in 100 days? 100 days. Yes, J is -1. Previous one answer J is -1, but it don't have answer. It should be J is -1. It's a mistake. Don't think this question. Joules per second. Okay. Instead of 1,000 bulb, sorry, 100 watt bulb, a 10 watt saving bulb were used. 10 watt saving bulb were used. If light is on 4 hours per every day, that means how many light unit saving? That means per 1 day, 10 watt over 1,000. That's a kilowatt. Kilowatt hours, 4 hours saving. Then 100 days, you can multiply 100. Then 30 to 30 cancel out. 4 kilowatt units save. 4, right? Yeah. Answer number 4. 4 kilowatt hour, but don't have answer. Hundred days, 4 kilowatt. How you got 36? 10 watt, then 10 over 1,000 kilowatt. 4 hours per every day. How much electricity units per saving per 100? Instead 100 watt bulb, a 10 watt saving bulb per use. Sorry, yes. Yeah, 10 watt bulb, this is the electricity usage. Then you have to get again 100 watt bulbs. 100 watt over 1,000 into 4 hours, 100 days. Then 3, it is 40. Yes. 40 kW watch. Then the saving amount is 36. Yes, good. Saving amount is 36. Eight. If the cost of electricity are 5 rupees per 1 kilowatt hour, 5 rupees per 1 kilowatt hour equal 5 rupees. 5 rupees. What's the cost for running a 10 ohm appliance for 6 minutes on 240 volt supply? 240 volt supply. Okay. Again, you have to calculate the power then. Power equal V squared over R, that we already discussed. The P equal VI. We can modify into P equal V squared over R. Then V squared mean 240 into 240 divide by R, 60. And 24, 4, 240, 480 plus 480, 960 watt. 960 per 6 minutes. 6 minutes. Now 960 divided by 1,000 for converting to kilowatt. kilowatt, then 6 divided into 60 per hour, convert into hours. Then it is 0 to 0 cancel. 6 to 6,000, it is 0.096 kilowatt hour. This much of per 6 minutes. Within 6 minutes, this is the amount of kilowatt hours used. This is the amount of kilowatt hours used. Okay, then 0.096 multiply with 5. 0.096 multiply with 5. What's the answer? 0.096 multiply with 5. 96 multiply with 5. 0.48, right? 0.48. Good. Answer number 2. Try these questions again. I think you already done this question. I'm going to rapidly complete and go to tutorial number 2, because tutorial number 2 is the very important one. They are very simple questions. Question number 9. The equivalent resistance of the circuit between A, B in the network shown in the figure. Okay, get the equivalent resistance that we discussed many practice questions in the lesson. 6 into 12. 6 into 12. It is parallel. 6 into 12 parallel. Then 6 into 12 into 6 divide by 12 plus 6. Then 12, 72. 72 into over 18. What's the value? 72 over 18. 72 over 18. 4, no? 18. No, 9. 72 over 18. 4, 4. 4. 4 plus 2. 4 plus 2 again 6. 4 plus 2, it is 4. 4 plus 2 again 6. 6 and 12 again parallel. 6 and 12 again answer 4. 6 and 12 again 4. Again 4 plus 2 6. 6 and 12 again parallel. Again 4. Methanat 4. Then 4 plus 2 again series. It is 6. 6 and 12 again parallel. Answer number 4. Understood? Yeah. Most possible MCQ questions. Okay. MCQ එකක් එන්න පුළුවන්, because if you know the method, you can within few seconds you can get the answer. If you don't know these short methods and basic things, you have to get at least 10 to 12 hours for this, 10 to 12 minutes for this question. Okay, understood? I'm going to move into next one. Amavi? The equal resistance across A, B network shown in the figure. Okay, it is very simple. It is two parallel resistance, A and B. It is like this. This 100 ohms. Now 110 ohm and 1100 ohm is parallel. Then we can get the equivalent resistance by short methods. Req equal 110 into 100, 110 into 100, 1100 divide by 110 plus 1100. 11 into 11, 121, 30. Divide 1100, 1210, 1210. 0 to 0 cancel. It is 100, like. Jehan, good. Am I correct? Why? Who correct this one? Shena, Mitu? It's a very simple one. Equal resistance as okay. Can I go to next one? Am I correct? 10th one? Good. It's 100. Three identical resistors of 12 ohm each are provided. 12 three identical resistance are provided. The value of resistance that cannot be obtained by connecting one or more of them. Okay, 36, the 12 three resistance, if I connect series, like this 12, 12 plus 12, it is 36, therefore it is okay. Impossible value is asking, cannot be attained. Then 12 resistor connect with series, 24 we can get, 24 okay. And 6, okay, 6 ohms we can get 12 resistance, 12 resistance connect with parallel, then 12 divided by 2, it is 6, it's also okay. 12 okay. Okay, how we can get 4 okay. 4 12 three resistance, all three resistance connect parallelly, then 12 over 3, the value 4, fourth, okay. But there is no way to get 2. 2 we cannot get. Understood? Simple question. Question number 12. Question number 12. A standard 3-pin plug has a grounding pin that is thicker than the other two. Thicker than, that means the cross section area is greater. 3-pin plug has a grounding pin. Grounding pin means the 3-pin grounding pin is thicker than other two. It is designed this way. What's the reason is asking? Because the grounding terminal must have higher resistance than other two terminals. Okay, correct. Let's see. Correct. Because the grounding pin must have higher heat capacity. No, higher heat capacity don't have relation. So that when the grounding pin is inserted, it opens the holes for other two pins, because grounding must occur first. No, they are wrong. To provide low resistance to grounding pin. Okay, what's the reason? First one also wrong, because grounding terminal must have higher resistance. Then when you increase the thickness, the resistance is decreasing. That's therefore this one also wrong. Okay, then what is the answer? You have two options. The 3 or 5. What is the answer? What do you think? Shena, what's the answer? 3 or 4? 3 or 5? When the grounding pin is inserted, other two holes open. 5, very good. Yeah, that's one also correct, but it is not the main function. It's not the main function. The answer number 5, because when increase the thickness, that means cross section area, the resistance is decreasing. That's why then the grounding pin, you can maintain low resistance, because that's the equation. I think you can remember the resistance equal rho L over A. L increasing, resistance increasing, A increasing, resistance decreasing. Inverse relationship, area and resistance. Remember. The potential difference across the resistance of 5000 ohm in the given circuit is measured by a voltmeter with resistance 5000 ohm. The reading of the voltmeter is the potential difference across the resistance 5000 ohm. 5000 ohm. This voltage is measured by a voltmeter with internal resistance. Voltmeter resistance 5000 ohm. The reading of the voltmeter is, what's the reading? What's the reading? What's the reading? Okay, first of all, you need to get the current flowing through this circuit. How many current is flowing? And the battery voltage 120 volt. Then V equal IR. The voltage 120 volt. 120 volt equal 7500 I into 7500 ohm. This is a full resistance, equivalent resistance. Then 0 to 0 cancel. The I equal 12 over 750. 12 over 750, very small amount is current is flow through this circuit. Now, the voltmeter used to measure the measure the volt between this 5000 ohm one. Okay, then we can get the voltage V equal IR again. V equal IR. V equal IR. The voltage is asking the I equal 12 over 750. 12 over 750 into resistance now 5000 5000 parallel, then 2500. 2500, 0 0 cancel. 75 25 3, sorry, yeah, it is 3. It's 40 volt. 40 volt. 40 volt. Yeah, a question why resistance 2400, because the voltmeter also has a resistance. See, eketh thiyena 5000 volt, 5000 ohm resistance. Then 5000 and 5000 parallel. No? Voltmeter always we connect with parallelly. That they are the basic things. Then 5000 5000 eketh thiyena internal resistance 5000 ohm. Then 5000 5000 parallel. Then 2500 is the 5000 over 2. 2500 is R. Then 2500 multiplied by 12 over 750. Answer 4. Answer 2. Clear me too? Yeah, if you use 5000, it is 80. But wrong. You have to read the question first. And you should know the always voltmeter connected to a circuit parallelly. The ammeter connected to the circuit series. Clear? Do I need to explain again? Amar? Amavi? Clear? Okay, they are possible rational MCQ questions. Okay. What is the current flow into the 8 ohm resistor, 8 ohm, 8 ohm, that means this one. In the circuit shown in the potential difference between P and Q is P and Q potential difference is 6 ohm, 6 volt. Potential difference 6 volt, 6 volt. Now it is a parallel resistor systems. Therefore, voltage is same. Current is dividing. Current is dividing. The question of what is the current flow into 8 ohm resistor? 8 ohm resistor. Okay, now think the voltage difference. V, voltage difference between P and Q, it is 6 volt. 6 volt. 6 volt. Okay, then we can find first how many current flow in through entire circuit. V equal IR. V equal IR. Okay, first V equal the full equivalent resistance 12 plus 12, 12, yes, 12 and 12, 12 and 12, then 12 and 12, it is the equivalent resistance 6, 12 over 2, it is 6. Then voltage 6 equal, it is 6. Then 6 to 6 cancel out. I equal 1 ampere. 1 ampere. 1 ampere is flowing through this circuit. 1 ampere. 1 ampere is the value. Then 1 ampere is flowing through this, and the both side equivalent resistance same 12, 12. Then it is separate 0.5 ampere and 0.5 ampere. 0.5 ampere. Answer number 4. 0.5 ampere. 0.5 ampere. 0.5 ampere. Clear? Any doubt, please ask. Don't keep any question, because this is a final month now. You have very simple, very few days. Now this is today's 6th, right? Next month 6th. It is final 3 days. Next month 6 mean only 3 days for the exam start. $15. As shown in the figure, a composite wire is made by connecting the ends of two wires of equal cross-section area but length L and 2L. This one L and this one 2L. And resistivity rho 1 and rho 2 respectively. This one rho 1 and this one rho 2 respectively. The effective resistance of the composite wire is effective resistance is asking. Effective resistance is asking. Okay. That means this type relationship is asked. Okay. Now, if I got the resistor of this first part, think this is A and I got it is A and it is B. Then I got A conductor part, the R equal rho L over A. Now, rho is rho 1, L means capital L. I'm going to change capital L. The cross section area same capital A. Now, if you got the resistance of next one, it is R equal rho 2 2L over A. Same cross section. Now it is R equal to rho 2L over A. Over A. Now, what is the full resistance value? The full resistance is asking the full resistance of the conductor. Then R1, sorry, rho 1 L over A plus 2 rho 2L over A. Okay, now you can add this two value, the A rho 1L plus 2 rho 2L. No. Rho L wait. the effective weight. Wait, I will check the original paper. I think it has mistake. Yeah, the problem is this one don't have answer. This is correct. Rho L, rho 1 L plus 2 rho 2 L over A is the answer. Don't have method to get this relationship. That's the problem. Rho 1 L, then we can get L out if you want. L out, it is rho 1 plus rho 2 over A. Yes. Now it is the full length. It is full length. We can say the one part is L. Then the total length is L plus 2L. It is 3L. Then it is 3L. 3L. 3L rho 1 plus rho 2. Rho 1 plus rho 2 over A. Over A. This is the answer. This is the answer. Yeah, this type answer is come. For given answers, don't have this type relationship, right? Okay, try to get this one again. Again, try this question to get this one. Okay, go to this one. The tree graphs A, B, and C show how the electrical resistivity varies with temperature for three different materials. Yes, that we already discussed in the tube. Okay, this is temperature in normal conductors. It is, and what is this? Okay, then you can select using answers. Okay, the first one, metallic conductor, superconductor, and semiconductor. No, only semiconductors, when temperature increase, the resistivity, rho, resistivity. Only semiconductors, it is decreasing. Resistivity is decreasing. With temperature increasing, resistivity decreasing only for semiconductors. Semiconductors, due to the free electron amount is increasing. The free electron amount is increasing. Therefore, the free electron amount is increasing. Therefore, the resistivity is decreasing. The conductivity increasing. Conductivity increasing. And it is normal metallic conductor, when the resistivity is increasing, the resistance is increasing. But superconductor up to certain level, when decrease the temperature up to certain level, the temperature gradually decreasing, but in a certain level it is become zero. It's become zero at a certain level. That's we called as superconductor. Okay, then answer metallic semi super. Answer number 2. Metallic semi super. Okay, the figure shows three identical bulbs connected in a circuit powered by a battery with zero internal resistance. The battery internal resistance is zero. Oh, therefore, don't need to think about. And ammeter is included in a circuit. It is internal resistance of ammeter also. Don't need to think, it is neglectable. The if the filament of one of the bulb breaks, what happened? Think one bulb is breaks. Then what happened to the this circuit? The ammeter reading decreases and brings ammeter reading decreases and the brightness of each of remaining bulb increasing. Is it correct? The ammeter reading decreases. Is it possible to decrease ammeter value? No. Ammeter value cannot decrease by if it is one bulb breaks. Think this one break, this one break. The ammeter value, it's no. It is a resistance is decreasing. Then ammeter value should increase. Ammeter value should increase. The ammeter reading decrease and it is decrease, not decrease. The ammeter reading increase and the remaining bulb gradually become brighter. Okay, that's okay. The ammeter reading increase and brightness of remaining bulb decreasing one by one. The ammeter reading decreases and while the brightness of remaining bulb remain unchanged. Answer number 3. Because when one bulb is broken, one bulb is broken, the resistance in this path is decreasing. Therefore, other bulbs get more current, then brightness increasing. Brightness increase. Answer number 3. Okay, final one. A 6-kilometer long underground cable AB consists of two parallel conductors of equal size, spaced apart, equal size spaced apart. At a certain point along the cable, a fault with current leakage came between two wires. During the testing of this fault, the resistance measured between two wires at the end A is found, it is 3 kilo ohms, and the B found 5 kilo ohm. 5 kilo ohm. 5 kilo ohm. Okay. What is the distance from AN to the fault point? AN to fault point. Okay, they are most possible MCQ question in the exam. 6 kilometer long underground cable AB. Okay, think this is the AB. Think this is A side. This is the B side. AB consists of two parallel conductors of equal size. Two parallel conductors, equal size. At a certain point along the cable, a fault with current leakage came between the two wires. Current leakage came between two wires. It has two wires, A and B, two wires. Okay, think this is the fault. This is a fault. Think this is the fault between two wires at end A is found. It is 3 kilo ohm. This part is 3 kilo ohm. 3 kilo ohm. This part 5 kilo ohm. 5 kilo ohm. Okay. How to get this? Now, from this distance is asked. L is asked. This distance is asked. Okay. Now, R equal rho L over A. Rho L over A. Rho mean the material type. Depend on the material type. It is same material. Same material. It is 3 kilo ohm. 3 kilo ohm. 3 kilo ohm equal rho L over A. Then we can get the L. We can get the L. Isolate the L. L equal 3A over rho. 3A over rho. This is the L. Then think it is L2. Think it is L2. Now, if you use again R equal rho L over A, it is 5 kilo ohm. Now, let's isolate rho. Rho equal 3A over L. L1. This is L1. This is L2. Rho L2 over A. Rho L2 over A. Now, 5A rho equal 5A over L2. Now this rho is equal. Rho equal. Now 3A over L1 equal 5A over L1, L2, L2. Now A to A cancel because same cross section, rho also same due to same cross section. Due to same cross section. Now the L1 equal L1 equal L1 equal L1 equal 5 3 3 sorry 5L1 equal 3L2. 3L2. Okay, that's the ratio. 5L1 into 3L2. Okay, that's the length. 5 to 3 is the ratio between. Okay, 5L1, 3L2. Okay, if you want to get L1 now, L1 equal you can isolate Okay, it is 5L1 over 5L3L2, then L1 equal 5 mean 5 kilo ohms. No, that means ohms 5,000. It is 3 kilo ohms 3,000. It is 50 over 30. It is approximate 1.8 kilometers. 1.8 kilometers. Okay. Okay, again go through these questions. They are bit thinking questions. Okay, let's move into our tutorial 2 questions. Tutorial 2 exam questions. The same type question again asking the exam questions. Okay. Okay, come to tutorial number 2. Other questions are practice questions. You can practice alone. If not, if you need, I will send you answers. Question tutorial 2, MCQ page. Okay. Are you complete this paper? Complete? Amar, are you complete this one? All? Is it finished? They all are exam questions. 26, 27, 28 questions in 2015 to 2024. Okay, question number 1. What is the answer? Question number 1. as shown in the figure, two wires of aluminium and copper with the same cross section area and length are connected to each other led to the current flow. The true statement regarding wire. Equal voltage drop across two wires, but different current flow through them. Now it is aluminium and copper, two conductors are series. It is connected series. Then equal voltage, no. Voltage is different, and but different current, no, not different currents. Therefore, first sentence is wrong, because same current is flow through this conductor because it is series connection. Equal voltage drop across two wires and equal current flow through them. Equal voltage, is it correct? Equal voltage drops across two wires and equal current flow through this. Different voltage drop across two wires, but equal current flow through them. Yes, this is the answer. Different voltage drop across two wires and different current flow through them. Different voltage and different current flow. Rate of heat dissipation of each wire is equal. Heat dissipation mean the power, no? Then P equal VI. If it is same voltage, same current is flowing, the voltage is different. Therefore, power also different. Answer number 3. Are you correct? Adisha, are you correct? Correct? Good. Go to question number 2. The number of turns in the primary and secondary coils of a transformer is 500 and 125 respectively. When 240 volts alternative voltage is supplied to primary coil, the output voltage of secondary coil is output voltage of the secondary coil. Okay, very simple. Yeah, this is the equation now. This is the equation. The question given, number of turns in the primary and secondary coils in the transformer 500 and 125. It is 500 and 125 primary and secondary respectively. When 240 voltage alternative current, that means AC current, voltage is supplied to primary coil. Primary voltage 240. Secondary voltage is asked. Then 0 to 0 cancel. 24 into 125. 125 into 24. What's the value? 125 into 24 divided by 50. What's the value? Amavi? Yes, 125. Yes, it is Vs equal 60 volt. 60 volt, answer number 1. Answer number 1. Again, same questions asking the variation of electric resistivity with temperature for 3 types of conductors are shown in the graph below. A, B, and C. Okay, the first one, with temperature, the resistivity is decreasing. What is a conductor? Superconductor. Sorry, semiconductor. Semiconductor. With temperature gradually decreasing, but certain time it is become zero. That is superconductor. Superconductor. Gradually increasing, it is normal conductor, metallic conductor. Then A, semi, B, super. Answer number 4. Answer number 4. Answer number 4. An ideal transformer that I already explained. The ideal transformer is transformer without any energy loss. It is given here. An ideal transformer has 100 turns in the primary coil and 200 turns in the secondary coil. When the primary coil is connected to 112 volt alternative supply, it gives 10 ampere current. Then the voltage of the current of the secondary is secondary coil voltage is asking. And ideal transformation 100 turns in primary coil. Okay, this is the equation as I told. Now this part you need to use 100 and 200 turns. 100 and 200 turns. When the primary coil is connected to 120 volt alternative supply. Voltage 120. 10 ampere, the voltage, again same question asking as previous one. 120 volt alternative supply. 120 alternative supply. The Vs 2 to 2 cancel. It is 240. Vs equal 240 voltage. 240 voltage. Now you can get the 100 over 200. Is over primary current is 10 ampere. 10 ampere. 10 amperes. Okay, then Is equal 1000 over 200. 5 amperes. Okay, any equation you can get the secondary current and secondary voltage 240, 5 volt. 240, 5 volt. 240, 5 volt. Sorry, 5 ampere. Sorry. 240 volt, 5 ampere. Question number 5. A very high voltage is used to distribute the electricity throughout the country. Yes, that I told. Normally, the electric current generate in the powerhouse by using step-up transformers. We going get into a higher voltage value. Then after that, using distribution system, we distribute entire country. And again, we use step-down transformers to distribute into the houses, distribute into village houses. The reason for this is, okay, what's the reason? That I already explained in the lesson. What's the reason? Send me answers. Send me answers. Ahmed, Shehan. Answer. Yeah. Shehan, Mitu, what's the answer? Amavi? Yeah, others, it is very simple thing. Yes, the high voltage improved to reduce. Yes, yes. Reduce energy loss. That means increase the efficiency of the distribution system. Increase the efficiency of the to transmit electric power. More efficiency. More efficiency. Answer number 4. 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 Okay, discuss question 5 questions. The in the previous paper, yeah, in the previous paper also same type questions asking. Same type. Question number 6. A high voltage electric cable consists of a steel conductor with resistance R and 6 conducting wires around it. Okay, understand, this is a very good question. A high voltage electric cable of steel conductor resistor, this one resistor RF, right? Sorry, RS, capital RS, the middle one, it is steel, and 6 conducting wires around it, 6 conducting wires around it, each with resistance RA, RA, as shown in the figure. If all the wires are insulated separately, they are all insulated separately, what is the resistance of the cable? What is the resistance of the full resistance of the cable? Okay, can you calculate? Can you calculate? Can you calculate? Okay, before calculate, tell me, it is like 1, 2, 3, 4, 5, 6, 1, 2, 3, and 7, and the middle one is different. Middle one is a different one. Middle one is a different one. Okay, that is series connection or parallel connection. Tell me first, series connection or parallel connection first. Is it series connection or parallel connection? Read again the question. Is it series system or parallel system? Series or parallel first? Tell me quickly, because we have a lot of things to discuss today. Series connection or parallel connection? It is a parallel connection. Yes, very good. It's a parallel connection, sure. Then it has 1, 2, 3, 4, 5, 6, 7. 1, 1, 2, 3, 4, 5, 6, and with middle one, 7 states, 7 conductors, 7 conductors, wires. Okay. What is the resistance of the cable is asking? The resistance of the cable is asking. The resistance of the cable is asking. Okay, how we get this? This one RS, then RS, the resistance of the full cable mean the equal to resistance, 1 over R EQ, 1 over R EQ, 1 over R EQ, 1 over RS plus 1 over r, sorry, a plus is 1 over r s plus 1 over r s plus 1 over r s 1, 2, 3, 4 plus 1 over r s and another 1 over r s. Now 1, 2, 3, 4, 5, 6, 7. Okay, that's the equation. Okay, now we can simplify this calculation. 1 over r eq equal 1 over r a plus 1. It is 1, 2, 3, 4, 5, 6. No? It is 6 over r s. 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 Now, we can get the common value r a. Sorry, remember, understand, 1 over r q, 1 over r eq equal the common value r a r s, and this one, it is 1 equal the remain value r s, because r a already available. The r s is the uh, yeah, r s is the r a r s, sorry, r a plus 6 r s, 6 r s. Now this is 1 over r q. Then our target is get the r q, r e q. That means equal to resistance, then opposite side. R e q equal opposite side r a plus, sorry, r a r s divide by r a plus 6 r s. Answer number 6 r s. Answer number 4, right? Okay, I got this one. They are bit advanced questions. Advanced question, not easy, but you need to understand the method. You have to understand method. Okay, that's a basic thing. 1 over r a plus 6 over r s is the 1 over r eq. 1 over r eq, then you can get this type. R a or r s take as a common value. Then it is r a plus 6 r s. 6 r s. Then the reciprocation is the r e q. Understood? Understood? Are you good? Yeah, that is question. Sorry. It is the point I have done mistake. It is the middle one is RS, no? Then it is RS. Make RS window. Now okay, meva RA. RA. I have changed this. RA. Then it is 1 endoni RS second. RS plus RA. Now okay. Now okay. RARS common RARS. Adish, now okay, right? I have changed here. That's it. This one RA මෙතන RS තියෙනවා, therefore RA මෙතෙන් තෙන්න and 6 RS, then reciprocation is answer. Okay, now note down. Amar understood? They are bit advanced. Amavi, can you understand? Bit complex. Now this is we have to understand this is a parallel system. It's a parallel connection. If it is parallel connection, you can see 7 cables. No, it's a 7 cables. This is a 1 cable. It is a steel, and other all cables are identical. 1, 2, 3, 4, 5, 6. They are identical, and the middle one is special one. It is steel. Then steel one, it is RS, and this one RA. Aniteva RA. Then R1 over REQ. That's a parallel. 1 over REQ equal 1 over RS plus. That's S mean the special one, steel one, plus 1 over RA plus 1 over RA plus 1 over RA plus identical 6 identical 6 cables. Then it is 1 over EQ equal 1 over RS plus this one. 1 plus 1 plus 1 plus it is 6, no? 6 over RA. Now 1 over REQ equal, we have to get the REQ, we have to get common value. RSRA, I got as a common. Okay, then RARS I got as common, then it is 1. Therefore, RS again no need. Therefore, 1 multiply with RA. This is 1 RA plus it is RA already available. Therefore, 6 multiply with RS. 6 multiply with RS. To get REQ, I need to get the reciprocation. Reciprocation is the RAS divided by RA plus 6 RS. Now, okay. Now, note down and try again after the class. Yeah, this type, no, this type at least two question this type advanced question in at least not at least maximum two questions in this type complex questions. Therefore don't think but practice it. Now we discussing all these advanced questions, that's why it's little bit tough these questions, but don't think practice. Shenan, now okay? Amavi, now okay? Okay, let's move into next one, seventh one. According to the Fleming's right hand rule, Fleming's right hand, that means the right hand rule we use for current induced to get the current formed due to a motion of a magnet in the magnetic field. The Fleming left hand rule we use for the force exerted to get the force exerted direction in the magnetic field. According to the Fleming's right hand rule, that means the current induction, right hand rule, when the forefinger, when the forefinger, thumb finger and middle finger like this, forefinger, thumb finger, middle finger of the right hand are formed in right angle to each other. They indicate respectively. Forefinger means this one. Then forefinger, always I told both the Fleming's right hand and left hand, both rules. The forefinger, that means index finger, it is showing the magnetic field, magnetic field. Therefore, answer number 2 correct, magnetic field. And thumb finger, motion direction, yes, motion direction, moving direction. And induced current is showing middle finger. Answer number 2. They are theory questions, very simple. Theory questions. Question number 8. When a car is started, its starter motor draws 50 ampere of current from the battery. 50 ampere of current from the battery of 12 volt for 102 seconds. How much electrical energy does the battery supply if its internal resistance is negligible? Okay, that is very simple question. Can you get this? When a car started, its starter motor draws 50 ampere of current from the battery. 12 volt. 12 volt. Okay, now the ampere and voltage is given, then we can calculate the P equal VI. P equal VI. The voltage is 12. The ampere is 50. Then 600 watt power is obtained for the starter motor, drawn for the starter motor. Then 600 watt mean per 1 second 600 watt, 600 joule, sorry, 600 joule, but it is used 102 seconds, sorry, 1.2 second, 1.2 seconds. You can get the 600 multiplied with 1.2. The value is 600 multiplied with 1.2. What's the value? 720 joules, right? Answer number 5. They are simple questions. Understood? Now I need to finish this. We have more 12 questions. We need to go rapidly. Okay, understood? This one understood. It is very simple thing. Please send me quickly. We have 20 more minutes. Okay, question number 9. A part of a domestic electrical circuit as shown in the figure X, Y, Z are 3 electrical apparatus in it. Which of the best position to fix a circuit breaker, that means fuse, in order to protect the circuit in the event of short circuit at any apparatus? Okay, where is the best position to connect circuit breaker? Break එකක් දාන්න කොහෙද හොඳ? Where it is most suitable place? A O B O C O D O E. Where? Mitu? A B C D. Yes, very good. A is the best position, because then we can protect all X and Y, all instrument. If I put B, it is not protective for X of X instrument. Therefore, A is the best position. A is the best position. Question number 10. An electric pump rise water to a vertical height of 48 meters at the rate of 5 kilogram per minute. What is the power of the pump? Okay, what is the power of the pump? What's the power of the pump? The gravitational acceleration 10. Okay, quickly get this value and send me. The electric pump rise water to a vertical height 48 meter at the rate of 5 kilogram per minute. 5 kilogram per minute. What's the power of the pump? Power of the pump. Power of the pump. Okay, first we can get the energy requirement within 5 minutes. Sorry, within 1 minute, 5 kilogram per minute mean we can get the potential energy. Potential energy equal mgh. mgh, mass 5 kilogram, gravitational acceleration 10, height 48 meter. Then 48 into 5, 232, right? No, 200. 40 into 5, 240. 240, 2400 joules within 1 minute. We need the power of the pump. No? Power mean within 1 second how many energy used. Then divide by 60 seconds. Js minus 1 is the power. 0 to 0 cancel. 240 over 6. 240 over 6. 240 over 6. Answer number 40 watt. Answer number 2. If in doubt, please ask. Any doubt, please ask. Any doubt, please ask. A hot water tank contains 170 kilogram of water at 20 Celsius. 170 kilogram of water at 20 Celsius. How long will it take to heat the water to 60 Celsius? 20 Celsius to 60 Celsius using an electric immersion heater, which is apparatus at the power of 5 kilowatt. The specific heat capacity of water is given. Then, okay, that's also very simple. Can you get this? 170 kilogram of water at 20 Celsius. How long? The time is asking. The time is asking how long it will take to heat the water to 60 Celsius degree. That means temperature difference 40. Okay. I can give 2 minutes. 2 minutes, Salingan. Quickly. Okay, what's the value? A hot water tank contains 170 kilogram of water at 20 Celsius. How long will it take to heat the water to 60 degree? That means 20 Celsius to 60 Celsius using electric immersion heater, which is operate the power of 5 kilowatt. 5 kilowatt means 5000 watt, remember that you already know. 5000 watt. The specific heat capacity is given. Yeah. First of all, you need to calculate the quantity of heat requirement. Quantity of heat requirement. It is Q equal 20 Celsius water heat up to 60 Celsius. The temperature difference 40, right? Then the water specific heat capacity is common. The Q equal mc theta. The mass of the water, it is 170 kilogram. The specific heat capacity 4200 J kg minus 1 K minus 1. The temperature difference 40 Kelvin. Kelvin to Kelvin minus 1 cancel out. Kg to Kg minus 1 cancel out. What's the value? Okay, it is 28,560,000 joule. Now the problem is, this is joules, then the power of this the power equal heater 5 kilowatt. 5 kilowatt mean 5000 watt. 5000 watt mean within 1 second 5000 joule is reduced to water. Then to get within to get the time you have to this 28 5 6 1 2 3 4 joules you have to divide by 5000 to get the how many seconds. 3030 cancel out. 3030 cancel out. Yeah, 5712 seconds. 5212 seconds. Yes, Mitu. That is a energy requirement, Mitu. But the question asks how many time required. What's the time requirement for the what's the time requirement? It is 5712 seconds. Answer number 4. Question number 12. 3 bulbs each rated as 1.5 volt, 0.5 ampere, and a resistor R are connected to a 12-volt battery as shown in the figure. In order to light the bulbs at the rated value means this value, what should be the value of R? The resistance value is asked. Resistor value is asked. Okay, can you get this? Do you need time? Could you get this? Can you get this? Okay, quickly try. And if you got the answer, send me. Okay. Anyone? Good? Mithun? Anyone got the answer? Not 8, then. Not 8. Yeah, you are very close. The bulb each rated 1.5 volt, and now you can understand this 3 bulb series or parallel. It is series. How about the voltage? Then the voltage is same. Voltage is same. How about the voltage? It is 1.5 is the voltage of the battery. 1.5. Then all battery required 1.5, 1.5 volt, 1.5 volt, all battery 1.5. Okay, now, and how about current? 0.5 ampere. 0.5 ampere, it is a parallel system, therefore it is current is dividing. Therefore 0.5, 0.5, 0.5 required for each bulb. Okay, first of all, now it is 1.5 for all. If I got the voltage difference of one bulb 1.5, for say all bulb it is 1.5. හැම එකටම මේක 1.5 because it is a parallel circuit, parallel connection. Now it is 1.5, then all 1.5 is a volt, then the voltage difference 12 minus 1.5, 12 minus 1.5, it is 10.5 is the voltage is the difference. The voltage difference is 10.5. Now V equal IR. V equal IR. The R is asking. Then how many ampere required for these 3 bulbs? It is 0.5, 0.5, 1 ampere, and again 1.5 ampere is required. 10.5 equal 1.5, because the current is dividing. Therefore, for each bulb we need to give current, because it is not same current is flowing. 1.5 ampere R. Then R equal 10.5 over 1.5. Check, is there any answer? It is 7, yes. Then I'm good. Okay, question number 13. Again, try these questions. Question number 13. It's a good question, I think. Four identical filament bulbs, identicals, all bulbs are identicals, are connected to a battery as shown in the diagram below. What is the correct statement regarding the brightness of the bulbs? Brightness of the bulb. Bulbs A, B, and D. It is C, A and B series. A, B, and C parallel. D is a separate one actually. D is a separate one. Okay. A, B, and D glow with same brightness. Is it possible? Is it possible? Normally think the the resistance of the batteries are, the resistance is batteries are, then think this line it is a 2R, this one only R. Therefore, more current is flowing through this path. Less current flowing this path. Think I1 and I2. I1 is greater than the I2. Why? Two identical bulbs. Identical bulbs. Therefore, the resistance is greater in AB path. Therefore, not same brightness. Brightness is difference. Brightness of bulbs glow in the descending order. C. A and B are very important. A and B both same current is flowing. A and B series. Therefore, it is not descending. Therefore, it's wrong. A and B, it is same current. Bulbs A, B, and C glow with same brightness. A, B, C. A, B, C, no. Wrong. A, B, C same brightness, wrong. Because current is dividing. Current dividing. Bulb A and B glow with same brightness. Okay. A and B same brightness. It's correct. A and B because identical, same current is flowing. A and B same brightness. While D does not lighting up. Yes. D means there is additional path. It's resistant R, but this line don't have any resistance. Therefore, the current is not going to pass through this bulb. It is coming this path because no any resistance. It is correct. It's correct. See, this question is easy. Bulb C glow with the highest brightness. That's correct. D glow with lowest brightness. D is not glowing. D not glowing. Answer number 4. Answer number 4. Question number 14. A conducting coil is attached to a center zero galvanometer. This is a galvanometer. Two identical bar magnets, A and B. This is A and B, North Pole, South Pole. You can remember. Yeah, you have a break after discuss more 6 questions. Make Do we need break now? Can't we finish this paper? We have but more 7 questions. Today we start 6 now. Do you need break? Others? Do you need break? Oh, take break after complete. Okay. Then take a break and come 9:20. I'm starting 9:20. Today I need to complete part of uh, the exam paper also. Mock exam number 6 essay part also. Okay, then join again 9:20. Okay, question number 14. A conducting coil is attached to a center zero galvanometer. That means normal galvanometer. Two identical bar magnets, A and B. You know, in bar magnets, this is North Pole and South Pole. North Pole and South Pole are placed by sides of the coil from equivalence as shown in the figure. That means in two sides. What movement of the pair of magnets? What movements of the pair of magnets along the dotted line? at the constant speed create minimum deflection of the galvanometer. With minimum deflection, the question asking how we can move these two bar magnets with minimum deflection. Minimum deflection means minimum with minimum galvanometer values. With minimum galvanometer values. With minimum galvanometer change rotation. Yes. Okay. The right side movement is donated by right side arrow. The left side arrow. Okay, in the first time, the A magnet rest and B magnet move into this side like this. This is rest. In the first time. Okay, this is the first one. In the second time, this one rest, B rest, and this move into this side. Both side, how about the galvanometer value? Galvanometer value both times same, remember. First answer and second answer both same. Why? This is a magnetic field. Electric field. In an electric field, a magnet is moving, a current is flowing. Then the current value same because same movement. If both move towards to the coil, it is a greater value. It is greater than this time. May palin degatam vada make a greater in the third time. If both side again it is same. It is same as this time. It is same as previous. Both into away from the coil. And yeah, one magnet into A magnet into this side and B magnet also this side. This is the, by this method we can get minimum. Yeah, this is a minimum deflection. Minimum deflection we can get by in the fifth one because other all are higher value is given more than fifth answer. Higher value is higher deflection is given than fifth answer. Understood? Understood? Okay, question number 15. Yeah, 15 is an important question. A battery, electromotive force. Okay, can anyone remember what's the meaning of the electromotive force? Electromotive definition, electromotive force, EM force. Quickly send me what's the meaning of the EM force definition, electromotive force definition. Electromotive force, Denith. What's the meaning of the electromotive force? What's the meaning of electromotive force? Shenan? Amar? Amavi? What's the definition of the electromotive force? EM force? Electromotive force. Electromotive force. No, not only potential difference. Potential difference, which time? Electromotive force, correct. Which type? Yeah, electromotive force is the potential difference between two terminals. Yes, yes. In which type? Without connected to a circuit. Without connected to a circuit. As in the lesson I told, if I got this type battery, you can see this is it is, if it is new battery, it has, it is 1.5, it is 1.5 volt battery. Okay, that's the potential difference between these two terminals, between terminals. Okay, it is 1.5. This is the electromotive force of this battery. Electromotive force of this battery, the electromotive force is the potential difference between two terminals without connected to a circuit. If I connected to a circuit, due to the internal resistance, the voltage between two terminals decreasing than the electromotive force. That means, you know, when I connect this battery into a circuit, the voltage of this battery decrease than the 1.5. Okay, that's why we call the electromotive force decrease than the, sorry, the voltage of the battery decrease than the electromotive force. Therefore, the electromotive force is a voltage or potential difference of terminals without connected to a circuit. Without connected to a circuit. Maybe that we called as a electromotive force. Understood? Understood? Shehan? Yeah, that's the electromotive force. And internal resistance is simple R. Yes, this is the internal resistance, simple R, is connected to an external load R, external resistance R, as shown in the diagram. The battery delivers a current I. Yes, positive to negative, a current I is delivered to the circuit. Consider following equations about the voltage. Consider the following equation about the voltage. That means VR, the voltage across V that we called as VR, remember. Across VR. Okay, this is statements given about VR. Statements given about VR. Okay, the VR, the first statement, according to V equal IR, we can say the V equal I into R. Is it correct? Exactly correct. V equal I into R. The VR is a voltage between this resistance R. Then VR equal I into capital R. Is it correct? It is correct. Now understand. Okay, now this is most important one. Okay, now if I mark first electromotive force direction. What is electromotive force direction? This is the electromotive force direction, remember. This is the electromotive force direction. Now I am going to apply Kirchhoff's second law for this circuit, this law. Kirchhoff's second law for this law. Understand? Kirchhoff's second law for this law. Okay, now I am going to start from this end and complete from same point. Okay, I'm not going to label the loop. I'm going to stop from this point. I think it is A point, and again I finish from A point. Okay, now I'm going to this, no any battery, this line no any battery, this line no any battery. This is a battery, then I think it is capital E. Capital E. because it is plus, because my direction and electromotive force direction same. Therefore, it is plus. I'm going to apply Kirchhoff's second law. Kirchhoff's second law. Kirchhoff's second law. E equal, it is electromotive force, it is plus. Okay, plus. Then I'm going to start from again this point. My direction and current direction same now. Okay. Then it is IR. IR plus no resistance, simple IR. Sorry, capital I, simple R. Okay. This is my Kirchhoff's second law equation. Okay, now we already know VR equal IR. VR equal IR. Then if I isolate this IR equal E minus I simple R. I got IR equal E minus I simple R. Understood? Then now you can, if you come to our second statement, VR equal E minus IR. E minus IR. VR equal IR. Now IR equal to E minus IR. Then we can say VR equal E minus IR. No? Like this. Now this is statement is also correct. If you have any doubt, please ask. Now VR equal E plus IR. E plus IR. E plus IR wrong because it is E minus IR. It is wrong. Above correct would be A and B only. Am I right? Good. Do I need to explain again? Yeah, that's a very little bit advanced question. Little bit advanced question. Amavi, could you get this? Good. Denith, know me? Couldn't understand? Okay, okay, very simple. Now the first one is easy, no? First one correct. First one exactly correct because VR make a voltage may R voltage. That's a VR. The voltage of the R resistor. Then it is V equal I multiply with this capital R. This is the voltage of the R resistor. Then in the second step, to get this relationship, I'm going to apply Kirchhoff's second law. Kirchhoff's second law. Then this one, no, only one battery, no. Only one battery. My direction and electromotive force direction same. See, it is I. So the E plus E equal my direction and current direction now same. Therefore, IR plus simple I, simple R I, IR. Kirchhoff's second law. අර අපි ලොකු circuit හැදුවේ. මේක very simple circuit. It's a very simple circuit. Now I am going to isolate IR. මේ IR එක isolate කරා. Then E minus IR is the E minus I simple R is the expression. Now E minus IR equal to IR. Therefore VR එකටත් එයා equal. IR equal E minus IR. IR equal to VR. Therefore VR also equal to I minus E minus IR. Therefore this one correct. It is not E plus I simple R. Therefore this one wrong. Then now, okay, you have to again try this question because they are little complex question, big complex question. This is the most important question. A metal wire PQR of 40 centimeter long is placed in a magnetic field of 0.5 T. 0.5 is the magnetic field magnitude. Okay. Parallel to PQ segment. It is parallel to PQ segment. It is very important. This is a PQ segment. It is parallel to PQ segment. It is very important. Now, what is the net force exerted on the wire segment when the current through the wire is 3 ampere? 3 ampere current is 3 ampere is the current. 3 ampere is the current. Now, what happened? Now, what happened? You already know what is the current. What is the when we that this experiment we already discussed in the lesson. I will show you. When we place any conductor, see, this is the experiment. Experiment I have complete with, I think, yeah, this is experiment. We discussed this experiment with videos. Yeah, this is the experiment. This is the experiment. Now, this is the current flowing conductor and magnetic field. Magnetic field. This is the N2S magnetic field. N2S magnetic field. N2S magnetic field. N2S magnetic field, and it is current flowing conductor. Then when we place any conductor, see, when we place any conductor perpendicular to this magnetic field, this is a magnetic field, we need to place the, okay, understand, we need to place this conductor part perpendicular to the magnetic field. If I place parallel to the magnetic field, no any force is exerted. If I place perpendicular to the magnetic field, then it is force exerted on the conductor rod. Okay, now it is same theory asking. When we place any conductor in a magnetic field, you can see 0.5 T magnetic field. 0.5 T magnetic field is the magnetic field. Okay, magnetic field direction is right side direction. This is the right side direction, is a magnetic field direction. But if I place this type conductor rod parallel to each, it don't have any force exerted. Any force exerted on this object, this PQ part. But QR part, it is perpendicular, not perpendicular, but it is not parallel. Therefore, force exerted on this QR part. QR part, remember, the force is exerted on the conductor. Therefore, we can calculate the amount of force exerted on this conductor rod. What is the equation? F equal BIL, that we already discussed in the lesson. F equal BIL. What's the meaning of F? The amount of force exerted, the value of force exerted. B mean magnetic field density. Field density. I mean current. The L is the length of the object, length of the conductor. Then the F equal BIL is the equation. BIL. B is the magnetic field density. That means 0.5. 0.5. I 3. L only 20, not 40, 20 part only. Now it is 10 into 3, it is 0.5 into 3, 20 centimeter we cannot substitute, 20 over 100. 0 to 0 cancel. 0.5 into 2, it is 1. 1 over 3, 3 over 10, 0.3. 0.3 Newton exert on this direction. 0.3 Newton. 0.3 Newton is a force exerted in this direction. But the problem is, it is not perpendicular. Now 0.3 is not given, but we can find the perpendicular. Always force in the Newton's Fleming's left hand rule. Now you already know it is always the exerted force is perpendicular to the magnetic field. This is a magnetic field. This is a magnetic field. This is a force. It is perpendicular 90 degree. Therefore, you can resolve this 0.3 Newton into this direction. 0.3 cos 60. You already know it is cos 60 because angle direction. 0.3 cos 60. Cos 60 value half. 0.3 into half. 0.15 answer number 1. Understood? Amar, would you understand? Denit? F equal BIL. Remember the equation. Please make a short note of this electricity lesson with all the equation and important things within this week. And complete all essay questions. Now I have given in the tutorial number 3, I have given you all essay questions asking the exam. Then I will give you in next exams, you will have extra essay question Wednesday exam also. Then please ready. Amav, is it okay? This one? Shehan? This is the question. This is a 2021 MCQ question. 47th MCQ question. Remember, this is 2021 47th MCQ question. If you go to last year exam again asking this same question with no any difference, only this line එක විතරයි නැත්තේ. මේ line එක විතරක් නැතුව මේ circuit එකම දීලා again asking but same question. Again asking same question that we already discussed. Okay, see this one. 6 resistors. and a battery are connected in a circuit as shown in the diagram, how many times of the power dissipation of resistor A as power dissipation of resistor B? This is a resistor A, this is a resistor B. Okay, I'm going to first, yeah, this type questions, it is 46, 47 questions now. Therefore, at least 5 minutes you need for this type questions. Therefore, in biology, chemistry questions, manage your time is very important if you need to get higher score. If you need to get higher score, at least 45, 46, 47 marks, time management in previous question, biology questions, ICT questions, chemistry questions, it is very helpful for maths part and physics part. Okay, then okay, this is bit complex question. You need lot of theories, all electricity theories you required for this type question. Okay, let's see. Okay, this is the circuit. I'm going to draw this circuit on my board. Is there any other resistance? Yeah, there is another resistor. Okay, this is R, this is V, and this is R, 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 2R. Okay, this is the circuit. The question asks, this is the A and this is the B. A and B power dissipation difference. Okay, P equal V, P equal VI, P equal VI. Therefore, don't need to worry. It has only one battery. Battery එකයි තියෙන්නේ. Therefore, it's not actually voltage. Okay, voltage V. Both voltage V. But the problem is, what is the current? What's the current flowing through this circuit? What's the current flowing through this circuit? Okay, then I'm going to mark the current on the circuit. Mark the current on the circuit. Sorry, I, for this path I. The problem on this point, it is dividing. It is dividing. Then I think this path I1. This path I minus I1. Remember, I minus I1 is the current in this path. I minus I1, as we discussed in the lesson calculations. Okay, this one also I minus I1. I minus I1. It is coming. I'm going to neglect this one. I think this circuit, it is then I1 again dividing. I1 again dividing. If you got this one, it is very complex. Therefore, I think this is I2, but I am not going to think about this one. Then it is I1. I think I1 and I minus I1 again add and again produce I. No, I think I1 coming from this end, I1, and This is I1. I think this one from this point again current divide. Again current dividing. Then it is, I think this is I2. I2. It is a bit complex. Try to understand this one. Then I1 minus I2. I1 minus I2. I1 minus I2. I think through B it is flowing I1. I1. May I1 එක මෙහෙම යනවා කියලා. Oh, yeah, it is easy if I change I1 and I minus I1. Okay, I'll change it. Okay, don't confuse. I'm going to change the current direction. This one I1. Only simple I changing. It is I minus I1. I minus I1. Then it is I minus I1 is flowing this through, and I1 is going through B resistor. Then I2 coming here. Then I1. Then again I come to this battery. Okay, this is my current of the circuit. Okay, current flowing through the entire circuit. Okay, then I'm going to label the circuit. Label the circuit. This is MCQ question. Therefore, don't need this type steps. But for better understand, you can write down. Okay, I'm going to start from A. When B, this is the C point. This is the D point, E point, F point. Okay, that's enough. Okay, now I am going to apply Kirchhoff's second law. I'm going to apply Kirchhoff's second law for my AB, C. මෙහෙම උඩින් A, B, C, D, E, A. That means outer path. Okay, then you can get electromotive force. Then if you got any path, only one battery, therefore electromotive force, my direction and electromotive force same, therefore E, capital plus E, plus electromotive force. Now I'm going to get IR product according to Kirchhoff's second law, IR product. Then it is I and R. I capital R. This is the point. This point, I capital R. And I'm going to I1 capital R plus my direction and current direction same. I1 capital R. Understand clearly. Okay, this one also I1 current. Then I plus I1 2R. I1 2R. Again, current is flowing through this. Then again I1 R. Then again no any resistor. Therefore, I can modify this equation E minus IR. E minus IR plus I1. Then 1, 2, 4I1R. 4I1R. Because 1 plus 2 plus 1, it is 1 plus 2, it is 3 plus 1, it is 4I1R. Okay, this is my first equation. Okay, then again I'm going to get now two unknown factors. With two unknown factors, we can't do this. Therefore, I'm going to again get AB. Understand the difference. AB, D, EA loop. That means this is my path, second path. lower path, I'm not going to consider this one. I'm not going to get this one. If you got this one, it is very complex. Okay, therefore I'm going to skip that and got this part, this one. Then we can get the relationship. The E, it is same. E is the electromotive force. It is positive because same direction. Now I R plus this one. I R, this one. I minus I1. I minus I1 R. I minus I1 R. This one. I minus I1 R. Then again I1 capital R. Then again no any resistor. No any resistor up to A. Okay, this is my second equation. Then E equal IR plus IR plus IR minus I1R plus I1R. I remove bracket and I got the full expression now. Now E equal IR plus IR. Here you can get plus IR to minus, sorry, minus I1R to plus I1R, you can cancel out. Minus I1R plus I1R cancel out. Now E equal IR plus IR 2IR. 2IR. E equal 2IR. Now you can get I, it is E over, simple, E over I equal E over 2R. Okay, this is the I. This is the I. This is the I. Then this I equal E over 2R is the I. Then what is the current flow into A resistant? A resistor, it is E over 2R. E over 2R. Remember very well. E over 2R. E over 2R. Then now I found the I. Then you can substitute to the whatever equation to get the I1. Simple. You can get I1. Okay, I'm going to. Okay, can you get and send me? Amar, I1. I'm going to get here. Now this is the equation, my first equation. Then E equal I. Instead of I can substitute E over 2R. E over 2R. E over 2R. Because I into R plus 4I1R. 4I1R. Okay, this is symbols. It is, if you understood the concept, it is very simple. Now R to R cancel. R to R cancel. Then E equal E over 2 plus 4I1 R. I need to isolate this expression I1. Okay, if you isolate I1, what's the value? What is coming? What is coming? Okay, now E minus 2 mean what's the meaning? E minus 2 mean half E. No? Then half E, if you go to this side, half E go into this side. E minus half E. What is the value? Again, half E. Half E. I got this point. This is half E. E minus 2 mean half E. Then half E, this is plus. Then when get into this side, it is minus half. Minus E minus half E. It is again half E is remaining. The half E equal 4. Now what is my requirement? I need to isolate the I1. I need to isolate the I1. I need to isolate the I1. Then I'm going to this point. Then E over 2, half E mean E over 2 equal 4I1R. 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 Okay, now I1 equal E over 4 into 2, it is 8. 8R. Yes, this is the experiment. I1 equal E over 8R. The I equal, get the difference, okay? Get the difference. I equal E over 2R. I1 equal E over 8R. Okay, that's a current difference. Then I1 equal, going to B, it is I1. Going to B, it is I1. The current is E over 8R. E over 8R. E over 8R. Then how many times? How many times? The question asks power dissipation difference. Power dissipation difference. Then the power is P equal VI. P equal VI. Voltage same. Voltage same. P equal VI. Voltage V. Then P equal VI. Again, the current difference in the power difference also, right? Current difference is the power difference. Then E over 2R, E over 8R, how many difference? It is 4 times. The B is 4 times than A current. A current, therefore 4 times. Understood or not? Can you do this type question, Hello? Amar, I got? You can try again. Okay? This is Kirchhoff second complex. Yeah, complex. No, I found, I use Kirchhoff second law to find I and I1. That means the current flowing through A resistor and current flowing through B resistor. The current flowing through A resistor, I got E according to Kirchhoff second law equations, E over 2R. Then according to Kirchhoff second law equation, current flow through B resistor, it is E over 8R. E over 8R. Now, if I got, now see, the I equal E over 2R. The I1 equal E over 8R. Now, what's the meaning of power dissipation? The power equal P equal VI. The PA, if you got power of A resistor, VI. I mean E over 2R. 2R. Then power A, PA equal VE over 2R. VE over 2R. If you got power B, PB equal V into E over 8R. E over 8R. That means PB equal power of B resistor It is VE over 8R. VE over 8R. Now the question asks more than A resistor, B resistor power dissipation, how many times? It is 4 times because it is 2R, it is 8R, it is 2 times. Sorry, 4 times. 4 times. 4 times in. Are we clear? It's not easy. It's time taking question. But 24 also same question asked. Okay, this one. A student made the following circuit using identical bulbs for a decoration. What is the current supplied by 80-volt battery? Yeah, middle one, 80-volt battery. If the resistance of each bulb 300 ohm, neglect the internal resistance of the battery. Then the question asks, what is the current supplied by the 8-volt battery? Okay, now V equal, this question for you. No any difference, V equal IR you need to use. The first one you need to find the equal to resistance of this system. Then the voltage 18, I is asking, if you substitute equal to resistance, this is the answer. Okay. Okay, calculate and send me what is equal to resistance. Equal to resistance. It is 3 ohms, then 300, it is 600. That one also 300, again 600. It is very simple. The opposite side also same. Then 600, 600, again 300, right? 300 plus 300, 600 plus 900. Clear? It is 900. This side 900. Opposite side also 900. Then 900, 900. 900, 900 again parallel. 900, 900 again parallel. This is 450. 450. Multiply with 450. Simple. Then I equal, isolate the I, 18 over 450. 18 over 450. Shehan, what is the value? 18 over 450. 18 over 450. What's the value? 0.04 ampere. Good. 0.04 amperes. 0.04 amperes. 0.04 amperes. But the problem is answers given in milliamperes. How convert amperes into milliamperes? Multiply with 1000. Then 0.04 multiply with 100, it is 4. Again multiply with milliampere. They are very simple questions. Answer number. Then if you want additionally, you can say milliampere from positive side of the battery. 40 milliampere is flowing through the circuit, and 40 milliampere again divide 20 milliampere and 20 milliampere into both sides, because both side resistors same. Clear? A fuse. Question number 19. A fuse made of a wire with a diameter D and a length L is blown off. A student is attempting to replace it with wire made of same material but with the diameter D over 2. What is the length of wire needed to replace the fuse? This is for you. Okay, that we discuss same type question. Okay, try to get this one. I can give 2 minutes. Is it 2L? No, no, no. See, not 2L. A fuse made of a wire with a diameter D and a length L, capital L, is blown off. If you need to off, this is the dimension. A student is attempting to replace it with wire made of same material. If we need to replace it, what is the requirement? We need to get the same resistor level. Okay, we need to, if it's not the off, blown off, time is changing. Therefore, we need to maintain same resistor value of the fuse. What is the length of wire needed to replace the fuse? Okay, now if you got the previous one, the R equal, you already know rho L over A is the equation. Now, rho L mean both the rho mean the material type. Material type is same material. Same material type is same. Now it is rho in previous, L, initial length L, and the diameter diameter D, diameter D, diameter D means, how about the radius? Why I mean it's like a cross section area is a circle. Then diameter you can't use for the area. This is the equation. It is the area you need. Area එක තමයි දාන්න ඕනේ අදීශ. Diameter you can't use. Then phi, the diameter d over 2. D over 2 is the radius. D over 2 squared. D over 2 squared. Now, the R, initial R we can say, initial R of the fuse, rho L over, sorry, rho capital L, rho capital L over phi d squared over 4. Because 2 squared 4, d squared over 4, this is the basic equation of the initial fuse. කලින් තියෙන fuse එකේ. Okay, if we need to replace that, this R value we need to maintain. Same R value we need to maintain. Okay, now okay, to maintain, I'm going to isolate the L now. Okay, let's do it later. Okay, now if you going to use replace it, R equal rho is same material, therefore I'm use rho. The L is asking, L we don't know, therefore I'm use simple L. The area phi into D2, D over 2 is the diameter. Then how about the radius? How about the radius? D over 2 is the diameter. Then what's the radius? D over 4, yes. Yes, very good. It again divide into 2, D over 4. D over 4 is the radius. Radius is squared. Area. Then R equal rho L phi into D squared over 4 squared, 60. Okay, now we have two expressions, right? This is the original one. This is the replaced one. Okay, now I am going to both. First, original one, I am going to isolate the L. Okay, the L equal, capital L equal, it is capital L. Then isolate කරාම මොකද? L equal yes, L equal yeah, we have to isolate the L, otherwise we can't do this. L cross multiplied. Cross multiplied phi R T squared over 4 divided by rho. This type value is coming. Okay, this is the L. Now the question is simple L. Simple L, what's the value? Make isolate karanna L. Isolate the L. Okay, now this one cross multiplicate. Phi R T squared over 16 over rho. Okay, now you can understand how many times length. The length should be 4 times less than the, not increasing, 4 times less than the previous fuse. 4 times less than the previous fuse. You already know when decrease the cross section area, when diameter decreasing mean cross section area decreasing. That means if we need to maintain same radius, so same resistance if you need to maintain, we need to decrease the length. Otherwise, when increase the length, the resistance increasing. When decrease the cross section area, also resistance increasing. Because when thickness decreasing, the barrier increase. Therefore, resistance increase. Resistance increase with the method the length should be decreased than the normal one. Therefore, now it is, according to this comparison, it is 4 times need to be decreased. 4 times. 4 times need to decrease, because it is 4, it is 60. 4 times. 4 times need to decrease, not increase. Why? Because when area decreasing, resistance increasing. This increased resistance to equalize, we need to reduce the length. If we increase length, the resistance again increasing. I got the point? Area එක අඩු කරද්දි resistance එක අඩු වුණානේ. හරිද? එතකොට අපි ආයි length එක වැඩි කරොත් ආයෙම resistor එක වැඩි වෙනවා. Now what is our requirement to equalize resistance? Equal කරන්න තමයි ඕනේ. Therefore, we need to reduce length of the conductor 4 times reduce. Now, this one L, therefore L over 4. L over 4 means 0.25. Understood? I got the point? Amar? Understood? Okay, question number 20. Consider 2 circuits arranged as a diagram. In the circuit P, a coil is connected to a cell and a switch. Yes, a battery and coil and switch. The Q is a coil is connected to a galvanometer. What will be the galvanometer reading when the following actions A, B, and C performed respectively? Okay. When the switch Okay, first of all, what is the principle of this? Now, this is when we on the switch, a current is flowing through this coil. Okay, when a current flowing through this whatever conductor that we already know, the electric field, and electric field is magnetic field. So magnetic field is exerted on the round surface, surrounding its magnetic field is T is form, magnetic field. Then due to this magnetic field, if there are any movement of this second coil, the galvanometer showing some current value. If there are any movement only. If it is rest, no any current. Rest if there are any movement only, it is showing some value. Okay, that's the theory. When the switch is turned on, when the switch is turned on, it start to current flowing. At this time, very small movement of very small rotation, very small indication we can observe in the galvanometer. It is not zero. It's not zero when the turn on. When the turn on, it is not zero. Remember, when the turn on karana velavadi, at the point of on the switch, it is showing some value. Then it is showing some value. When the switch is kept on, it is rest, no any value, because if I only movement only, it is forming some value, then no any value. When the switch again turn off, again it indicate very small value, then turn off also show value. Then answer A, it is given 0 and non-zero. No? A and C non-zero. If it is rest, it is 0. B 0. Question number 21. Again, same question asking. See, this is 2022 paper question. 2023 paper also same asking you. This is for you. Okay. The diagram show a fixed coil connected to a center zero galvanometer and movable magnet. Movable magnet mean the NS1. Consider the following situations. Moving the magnet rapidly towards the coil. Under which situation galvanometer deflection can be expected? Okay, first one, moving the magnet rapidly towards the coil. Is it correct? Is it possible to observe deflection? Amar, is it possible to observe deflection? Yes, exactly. Very good. Yes, exactly. Good. Keeping the magnet stationary inside the coil. Stationary, that means no movements. If there are no any movement, it is not pulling out the magnet kept inside the rapidly. Yes, that's also showing some deflection. A and C only. See. Question number 22. Four identical bulbs, PQRS, each rated 1.5 volt and 100 millivolt. Sorry, 100 milliwatt I used to make the following circuit. Used to make the following circuit. Consider the following statement regarding the circuit. Okay, the P, Q, R, and S all are identical bulbs. Identical bulbs. Same. Consider the following statement regarding circuit. The intensity of bulb PR. See, if you go through these questions, if you analyze, let's do again analysis class in this time. Try to get 2 hours for analyze few questions in. If you analyze this question, you can see the question pattern again and again. Same pattern is asking. Only diagrams, only statements are different. The question pattern is always same. You can understand. Okay, this type question we all already did in මේ වගේම එකක් කරා නේද මෙතන. See, this one, it is same question again given with symbols. See, consider the following statement regarding. Now this is the battery. Now you can see through this, if it is I current through this part, it is going I, flowing I, then through P it is I, and on this point it is current dividing I1 and I minus I1, that you already know. Then it is different. Now the question asks different statements. The intensity of the correct one asking, the intensity of the bulb P is higher than the intensity of the bulb Q. Yes, P is higher than the Q. Is it correct? Yes, definitely, because from this point the current dividing, but the full current going through the P1. Correct. The intensity of the bulb R and S are the same. R and S are the same exactly because same current is flowing. The intensity of bulb Q is twice the intensity of bulb R. The intensity of Q is twice the intensity of bulb R. Is it correct? Okay, tell me, is it correct or not? Q is twice the intensity of bulb R. Correct or wrong? Adisha, correct or wrong? Others, Amavi? The intensity of bulb Q is twice the intensity of the bulb R. Okay, what's the value? Not value. Is it correct or wrong? Amar, is it correct? The intensity of bulb Q is twice the intensity of bulb R. Correct or wrong? Wrong. Why? Okay, think if it is I equal 10 ampere, 10 ampere is flowing through P, then the full current is flowing through the P bulb. P again 10 mayana. In the dividing point, it is R and S. If you think 1 ohm, 1 ohm, 1 ohm, for example, because identical bulbs, then how about the current is flowing through this path? Think if it is then it is 1 ohms, V equal IR. Think it is 2, 2 and 2. Yeah, voltage V. Yeah, from this one it is flowing 6 amperes as example, 6 amperes. If it is 10, it is divide actually 2 times than this one. That means this is 2 and 2 or 1 plus 1, it is identical bulbs, no? Identical bulbs, therefore the current is half. Actually, if it is as example, the current flowing through this part 5 ampere, this is only 2.5. This is only 2.5. Why? The resistance 2 times, the resistance value 2 times than Q. Therefore, actually the intensity Q 2 times than the R. It is correct. Amar, it is correct. I got, think it is 7.5 ampere. 7.5. If it is 5 ampere going through this path, only 2.5 going through this path. Why? It is the resistor value 2 times. If it is 1 ohm, it is 2 ohms. 2 ohms. Due to high resistance, only half current is flowing. Understood? Therefore, it's correct. Correct is statement 5. Amar, I got. Okay. Okay. Then you have 24 questions we already discussed. You can try again. You can understand the same question pattern again asking same question pattern. Okay, if you practice Now today we practice old question in 2015 to 2024, all electricity questions, MCQ questions we practice. In your paper also, same type, 2 pattern question asking. Therefore, now don't need to worry about electricity questions. If you go through this question again, and if you practice one more time, then definitely you can, in the exam time, you can analyze answers and get mainly 46 and 47 question exactly coming from this electricity part. In 46 and 47 questions bit advanced, that's why this electricity questions little bit advanced. Okay, that's the end of our electricity discussion. Then you have a task. Now you have a work. Complete the remain part of the tutorial 1 and complete the full of the tutorial 3. If we have time, we can discuss tutorial 3 also today. Now 11, now 10:55. Okay, then okay, again go to these questions. Then you can understand in the analysis class I will explain. It is again asking same type, same pattern question, asking again and again. Okay, let's discuss other MCQ patterns in the analysis class. Okay, any doubt in electricity? Don't think they are little bit complex, but maximum 2 questions coming, maximum 2 MCQ questions coming. If you go to essay electricity questions, they are very simple. Okay, last week we already discussed 2015 electricity essay question we discussed. It is simple, but only MCQ questions little bit advanced. Okay, in the tutorial number 3, I have given every essay questions in the exam. You can try this question and okay, this is the 2016. See, it is asking electricity bill question. 2015 also electricity bill question. A house. Okay, now after class you can try these questions. A house of 10 filament bulbs rated 230 60 watt. Actually, if you practice these MCQ questions again, you can do any essay questions now. Yes, again this kilowatt hour question asking electricity bill related, P equal VI related, P equal VIT related. Okay, this is Fleming's left-hand rule. Okay, let's schedule time for discuss only difficult question. This Kirchhoff's second law. Okay, try. Tomorrow you don't have class, I think. Tomorrow evening. Okay, you can use this time for this tutorial. Okay, for essay practice, practice these essay questions, you need some time. Okay, if you practice in the your paper also electricity essay questions, you can easily complete and get full marks. Okay, electricity question if you select, electricity essay question if you select, it will be very easy for score, because very simple parts asking in electricity essay parts, not like MCQ. Okay, you can go through and check, and I recommend select the electricity part. If if you select, you need to practice very well in electricity equation, prepare a short note and practice very well. These equations again and again, write down and practice. And these MCQ questions, today discussed MCQ questions, practice again and again. Then practice all equation pattern. And if you practice these all questions in essay tutorial tree, you can select electricity question also. Okay. Any doubt from today's discussion in electricity lesson? Okay, if you want, I will now I will upload electricity all tutorial I already uploaded, and what else, all recordings I will upload in the group. Go through and complete within tomorrow every parts in electricity, because lot of questions coming in electricity for Wednesday exam. Okay, any doubt? Any doubt? No doubts? Okay, the other thing, this electricity today discuss this MCQ paper, MCQ questions bit advanced. Okay, don't afraid for this question, because these questions coming, as I told, the final 5 questions of the MCQ paper. That's why they are difficult. Okay, මේවා මේ අර අන්තිම 46 47 48 questions වල නිසා තමයි difficult. But if you practice essay questions, not much difficult like this, not advanced, you can try. Practice කරන්න, try කරන්න, then you can get, if there are any, if there don't have option, you can select electricity question also. Okay. And you have very limited time now, only 30 days, less than 30 days. Within this month you have only 24 days. Next week, don't think about next month, because next month you have another works. You have another special working program for next month. Therefore, every completing part. Now I think no any thing to discuss in lessons. Okay, I hope no anything to complete in lessons. You already complete without ICT all lessons. I think you completed, you covered. Okay, with today tomorrow you can practice electricity and complete everything. Okay, then 100% complete. Then you have only 24 days in this month. This is the final 4 weeks, not 4 weeks. 7 plus 7, yeah, only 3 days. Then this is the final 3 weeks you need to work. Don't think about final week. Final week you have to work on your first subject. I think ET and BST. You have only 3 weeks to work all 3 subjects. Otherwise, you have to stop SFD and third subject. You have to go for BST or ET. Only entire day you have to work on BST or ET. Therefore, only you have 24 days for work like this. These 24 days very important, because if any part, if you missed, cover everything and practice again and again and again, practice everything and improve very well, and stop these 2. You can stop after that. In the final week you can stop other 2 subjects and only work on your first subject. If you work very well, don't need 1 week for this one. If you 4 days, if you got for BST or ED, it's enough actually. Then otherwise, it is very difficult to after complete SFT, after complete BST and ET, again you come to SFT. It is very difficult. It is very difficult to refresh. Therefore, don't take more time for work on one subject. Don't take like this. If you work this time very well, you can minimize this time. You can minimize this time if you work very well within this final 3 weeks. You have only 3 weeks. It is very short time. Okay. I hope now you all working very well. But the time management and your working plan preparation, everything, now this is a final chance. Don't keep anything to do at the last moment. Complete everything within this 3 weeks. Okay. Okay, that's all for today. Then let's take another few hours for our essay part discussion. Okay, good night.